Hello, everyone. What I want to do now is go over duration. And in another video, I'll discuss approximation with respect to duration. So the idea of duration is extremely simple. It's simply the sensitivity of prices of an annuity to interest slash yield rates. So the simplest way to do this, to measure the sensitivity of prices of an annuity to yield rates, is modified duration, and that is just to take a relative rate of change of price with respect to the yield rate of an annuity. So we're taking the relative rate of change of the price of an annuity with respect to the yield rate of that annuity. So I, from now on, is going to be just a per period yield rate. Okay. And towards the end, I'll discuss how to do this with respect to term structure of interest rates, i.e. with respect to spot rates. But I don't see any problems on the exam FM sample problems that use that, so I'm not going to really dwell on it. But yeah, for the purposes here, you have one single yield rate that this whole annuity, excuse me, is being priced at. So the formula for the relative rate of change is just P prime over P. I don't want to get into what that means. I discussed that in detail in the force of interest video and the one after that. So go back to that if you want examples of kind of what relative rate of change means. And we put a minus here because, well, for prices of an annuity, the relative rate of change is always going to be negative, and minus makes it positive. Just makes life a little easier. Okay. So a concrete example, and one that's important for exam FM, at least it's in the sample exam FM problems, is a perpetuity of K at the beginning of each year. So the price of such annuity, you should remember, is K a double dot beginning of each year. It's annuity due. N is infinity. Here we have an interest rate I. And that's just K 1 plus I all over I. Well, divide 1 plus I over I. It's 1 plus I to the minus 1. So we can get the modified duration very easily. Just take the derivative of P with respect to I, holding K constant. Just drop the minus 1, subtract 1 from the exponent, times K. Derivative of 1 is 0. And pull out the K. All of that divided by the price, which is just K, 1 plus I to the minus 1. K's cancel out, and the minuses cancel out. And if we multiply top and bottom by I squared, we get 1 in the numerator. I squared times 1 plus I to the minus 1 is I squared plus I in the denominator. Okay. All right, so we have this nice simple formula for modified duration. Okay. So Macaulay duration for our purposes right now is simply 1 plus, pardon me for a second. It's just 1 plus I times modified duration. So I'll make a separate video on how to interpret Macaulay duration as a sort of average time that the bulk of the present value of an annuity occurs at. But that's going to require some probability theory, in particular, the expected value of a discrete random variable. I'll briefly mention that towards the end of this lecture, this video rather, but for our purposes, it's 1 plus I times the 1 plus I times a modified duration. There's no standard notation for Macaulay duration. I heard one person use MACD. Actually, the woman who wrote solution videos to the exam FM sample problems, she uses MACD. Some people just use D. I don't know. I like the way MACD sounds, so I'll use it. All right, so let's dive into an example, and this is 124 in the sample exam FM problems. So Rhonda purchases a perpetuity, $1 at the beginning of each year. Perpetuity's Macaulay duration is 30 years. I'll explain. Well, as I mentioned, you can interpret Macaulay duration as a sort of average time that the bulk of the annuities present value occurs at. So that's why this is sometimes used with units of years or whatever time period you're using. So yeah, be aware of that. Kind of weird, but and I'll explain it a little bit later on and in detail in another video. So if the Macaulay duration is 30, calculate the modified duration. Okay. All right, so this is pretty straightforward. Pardon me a second. So we're given 30. Is 1 plus I times the modified duration. That's what the Macaulay duration is. Sorry. Okay, and just plug and chug 1 plus I times the formula we just got for the modified duration of an annuity in perpetuity with payments at the end of each year. That is just 1 over I squared plus I. You can factor out an I here in the bottom. And it's just, 1 plus I, so I squared, same thing. So this is just 1 over I. Okay. So 1 over I is 30. Right. So let me go back to the calculator real quick. Right. So I'm going to store that in the one spot. So I'm not going to go back to the calculator because I have I, and all this is asking for is a modified duration. So I'm just going to take this, which is I plus I squared. And then take 1 over, and we get 29.03, which is right here, 29.03. So yeah, very straightforward problem. Again, don't worry about the years here. That's a little strange. Sometimes they use time units, and sometimes they don't. Yeah, and it is very strange because if you think about it, relative rate of change is unitless. So depending on your interpretation, Macaulay duration is either unitless or units of time. And I don't think there's one correct interpretation. But anyway. All right, so another example is a perpetuity of K at the end of each year. So we know what the price of that is. It's just K over I. So take the price is K over I. K is constant. So take the derivative with respect to I minus Ki to the minus 2. Just drop the exponent, subtract 1 from the exponent. Divide by the price, Ki to the minus 1. Minuses cancel. K's cancel. I to the minus 2 over I to the minus 1 is I to the minus 1. Is 1 over I. Okay. All right, so we have another example. Another very straightforward example. Actually, all these are pretty straightforward. I haven't seen a challenging Macaulay duration, modified duration problem yet. It's a little strange, but maybe they are this easy on exam FM. I have to look into a study guide. I would say for knowing what the exams are going to be like, probably the gold standard is the ASM it's a study guide by Harold Cherry. Anyway, okay, so yeah, so for this problem, just use our formulas here. Particularly, let me use formula here for modified duration. Okay. So we're given 17.6 is Macaulay duration 1 plus I MD. Okay, remind you this is MACD. So dump this into our formula, or sorry, it's dump MD, the formula for MD in the context of perpetuity with payments of K at the beginning of each year is just 1 over I. So one thing I want to make clear in both of these problems, it's completely superfluous for them to tell you what the price is, the payments for the annuities. It's totally irrelevant. I think it's just to trick you up. I'm not sure why they tell you it, probably. All right, so this simply becomes, you can solve for I here directly, multiply by I, subtract an I, whatever, or just divide out. This is 1 plus 1 over I. So 16.6 is 1 over I. So I is 1 over 16.6. Let's go get that. 1 second. Okay, so I'll store that. I don't think I need to store it, but I will store it. All right, so what's this problem asking for? It's asking for calculate the Macaulay duration using an annual effective interest rate of 2I instead of I. So we figured out what I is. So let's just multiply by 2. So I'm going to store this. So this is what 2I is. And so let's just use Macaulay duration. It's just 1 plus I times modified duration. Modified duration with respect to this 12% interest rate roughly is just take 1 over times 1 plus this interest rate of roughly 12%. And we get 9.3. Again, just plug and chug with respect to this interest rate of roughly 12% that we calculated. And sorry, this is 176. And lo and behold, we have the right answer, 9.3. Okay. These are some weird numbers here, but anyway. Okay. Yeah. So let's move on. Okay, so we have looked at a bunch of formulas for modified duration, and subsequently Macaulay duration. Whether you memorize these formulas is up to you. I personally wouldn't. For example, I would just remember modified duration is minus P prime over P. You kind of have to memorize that. There's no way around that. And then if I needed the modified duration of a perpetuity of constant K at the end of each year, at the end of each period rather, I would just remember the price is this, and therefore modified duration is just minus P prime over P, which turns out to be 1 over I. That would take me literally 5 seconds to do. But if you prefer to memorize versus read derive, it's up to you. I'm just terrible at memorization, so just do whatever you're better at. But a lot of times you're not given a specific situation like it's a perpetuity. You're just given a cash flow. Basically, you're just given there's payments at time, whatever. And they're particularly different payments. So what do you do then? Okay, well, so let's say we have this time diagram here, same thing, cash flow. I just have money at these times. I apologize for the really crappy looking picture here, but you can at least read it. It's K0, K1, all the way to Kn, T equals 0, N. Right, and we can get modified duration very easily. Yeah, I don't know if, I guess you could rederive it each time for a cash flow, for a time diagram. Might at least be good to memorize what we're going to do in a second. But clearly the present value, the price, and interest rate I per period, just discount everything appropriately. Nothing to that. And therefore modified duration is P prime over P. Well, I'm going to differentiate this with respect to I. So when T equals 0, the derivative of K0 is just a constant. So yeah, really, you get this, I guess, if you just want to use the, so go back a second. So ignore the denominator, that doesn't change. The denominator is just the price with respect to interest rate, I. But yeah, just strictly speaking, use the power rule, drop the minus t, subtract 1 from the exponent, you get the following here. But when t equals 0, it's just 0, so it's really t equals 1 to n, right? And if I take this and multiply by 1 plus I get rid of a v in the numerator. So I have this really nice looking formula for Macaulay duration. And if you have taken a Math 362 or taken a probability course, this might look a little familiar, sort of. And this should be you should kind of think, oh, this kind of looks like the expected value formula in some sense. And there is a video where I go over exactly that. If you're curious, okay, second. It is right here. This is an ad for booking, but yeah, so this video in the playlist, Macaulay duration as a weighted average. You'll get what the proper financial interpretation of Macaulay duration is. And it's basically like an expected value. It's sort of like an average time where the bulk of a time diagram occurs. I'm pretty precise in this video. Anyway, it's a little unfortunate that with Exam FM, you don't have to know that at all. You don't have to understand Macaulay duration one bit. You just have to play around with it with formulas, but it is what it is. Yeah, so this is pretty plug and chug. I'll go through some examples quickly. And one thing I really haven't emphasized, or I haven't touched, the cash flow keys. Using the cash flow keys, I suppose it's a little tiny bit easier. I don't even want to say it's quicker, because I don't think it is quicker necessarily. Might be a little easier to use the cash flow keys to get the price at a certain interest rate. But even that's debatable. So and so how do you get the price? You just take the net present value of your time diagram, i.e. your cash flow. That means something, great. Otherwise, I don't know. It's worth it to go through. All right, so easy peasy problem. So yeah, let me show you where this problem is done. So actually prior in the video, I do these kinds of examples, but the numbers are off because the numbers are likely, not always. I think actually I should double check, but the numbers are likely from the old Exam FM sample question list. This is new as of about a year ago. I don't think there's been updates to it since a year. Check. Yeah, so we're going to do this problem here. These are great problems, as I mentioned before. The only issue, there's two issues. One is that it's not updated too often, so you sometimes will do just pointless problems that are not going to be on Exam FM. There's not too many of them, so it's not a big deal. The much bigger issue, I don't know if it's an issue really, but just something to be aware of is that a lot of these problems are pretty damn easy, and they're way easier than you'll see on Exam FM. So this example here, 101, yes, it is part of the sample questions, the SOA sample question PDF. That's right here. But this is, you're not going to see a problem like this on Exam FM. This is way easier than you would see on Exam FM. So don't do this problem and be like, oh, well, great, I'll probably do this. I'll probably see this on Exam FM. That being said, I know people have done like literally every single problem here on the website, which is good if you're really, really, really pressed for money because this is free. I think you'll be fine if you could do every problem here quickly. But I still think Coaching Actuaries or Study Guide, like actuarial study manuals, the Infinite Actuary, I think it's worth its money, in my opinion. But anyway. All right, so we have cash flows are the following. This is just describing a time diagram, calculate the Macaulay duration. Okay. So this is pretty easy plug and chug stuff. I would say the important thing here is I want to show you how I would do it on the calculator. Right, I'll just write stuff down first, and then plop in calculator. Really all there is to it is the formula here. So T equals 1 to N, T KT VT, T equals 0 to N, KT VT. Bottom, of course, is the present value of your cash. So yeah, 40,000 at time 2. So I'll at least start this. Yeah, so I'll even do it exactly like it's here. So Mac D, try to write this very quickly. This time, 2 times 1,000. Interest is 7%. So what I would do, move this over. I'm out of room. Second. Yeah, what I would suggest doing, honestly, is get the present value factor and store it in the calculator. So it's going to be 1 over, it's going to be, you can just do a recall something and then squared. That's just going to be a little quicker, in my opinion, rather than doing 1.07 and minus 2. Uh, Second. Bear with me. Um, yeah, we gotta use a brush instead of a pen. Um, so 3 times 100,000, 25,000 rather, times 1.07 times 3, and then make this bigger. Second. Okay, plus 400,000 times 1.07 minus 4. This whole thing over just the present value of your cash flow. So discount 40,000 by 2 years. Discount 25,000 by 2 years. Discount 100,000 by 40. Okay, so yeah, let's do, it doesn't matter which one you do first in the calculator. All right, let's just plop this into calculator. So yeah, as mentioned, I would do 1.07 and over and store that in the one spot. Right. So yeah, so we have 80,000 times we call 1 squared plus 3 times 5,000 times recall 1 cubed plus 400,000 times recall 1. All right, 436,225.52. Store that in the 2 spot. And one thing I actually cut some stuff out, but for a couple of minutes I was not doing equal, and just it was a weird order of operations that was screwing things up. So do hit equals to be sure things are going to come out right. That was really struggling to figure out what's going on. Okay, so now let's get the denominator. 4,000 times 1 squared. 5,000 all 1 to the third plus 100,000 recall 1 fourth. All right, so I have this. I'll just divide this by this number here and then do 1 over. And hopefully this is one of the answers. And lo and behold, it is. It is D 3.3 or 3 point. So yeah, easy peasy, not much to this. Okay. All right, one more problem, which is just the one prior. Problem 100. It's not too bad a problem. We have 2 annuities. We have the Macaulay duration of the first annuity is 0.93. They have the same yield rate. Figure out the Macaulay duration of the second. Right. So not much, not all that much to this. And all right, so let's start with annuity A. You don't really have to draw a time diagram, but if it helps, do it. Down. Okay, so 0, beginning of each year for the first 3 years, 1, 2, 3 here. Make this a little better. Okay, so 1, 1, 1. So plop into the formula. So it's remember, right, we start at t equals 1. So it's going to be v plus 2v squared. And then present value of this time diagram here is 1 plus v plus v squared. And we're given this equals 0.93. So let's just go with this here. So you have v squared plus 2, v plus 2v squared equals 0.93, 1 plus v squared. Simplify, and what will you get? I'll do quadratic formula in a second. Another lovely quadratic formula problem. So this gives me 1.07 v squared plus 0.07v minus 0.93 v negative v. So as usual, we exclude the negative because that'll give me a negative answer. So I'll get the square root first and then deal with this. Over 2a to 1.06. Seven squared minus 4 times 1.07 times 0.93 negative equals root minus 0.07 over 2 times 1.07, and we get roughly 0.9. Store that. All right. Yeah, so let's go back. So this next one is this, sorry, we want B. So B is the same thing, except we have an extra one at t equals 3. So now this is just easy plug and chug. Annuity B. One, 2, 3, 4. Yes. Zero, 1, 2, 3, 4. 1. All right, so this is just v plus 2v squared plus 3v cubed over 1 plus v plus squared plus v cubed. So now this is easy. Get the numerators first. This plus 2 times squared 3 times 1/3. So 2 spot, get the denominator. 1 plus recall 1 squared plus recall 1. I forgot to do plus recall 1. See. Yeah, I did forget it before. So now yeah, and so 1.37 roughly, or 1.369. It's really annoying because the degree of accuracy on exam FM it changes wildly from problem to problem. Some problems will get very accurate answers, some won't. It should be consistent. What are you going to do? Yeah, so